Okay, this is a video for section 6.3 in your book on what's called the law of cosines. And essentially the idea is we care about being able to solve triangles, finding all the angles and all the sides. We know if I have a right triangle and I know one of the sides and maybe this angle, using my trig, my SOHCAHTOA and my Pythagorean theorem, I can manipulate that and find everything I need. We've already done that. Last time we did the law of sines, where if I have a triangle that isn't a right triangle, if I say know that that's 35 degrees and this is 8 and this is 20 degrees, given this particular ratio, an angle to its opposite side, then I can use the law of sines and I can get all the other sides and angles there. That's what we did last time. What we want to look at today is if we have the case where we have something like this. Say that's 40 degrees and this is 10 and that's 12, and try to solve that triangle. And the problem is we know from the law of sines, I can only use the law of sines if I have a ratio between an angle and the opposite side. In this case I don't have that. This is the included angle on those two sides. So the law of sines doesn't work. It's not a right triangle, so the Pythagorean theorem doesn't work. And we're kind of left with, what do we do? And what we can actually do to solve these is use what's called the law of cosines. Your book actually gives 3 different versions of it. This is the one for A. A squared equals B squared plus C squared minus 2BC cosine A. Your book gives another version solved for B squared and solved for C squared. They're all the same. It doesn't really matter. They mean the same thing. Whatever side you want to find A squared, square the other two sides and add them together, and then subtract 2 times the 2 other sides times the cosine of the angle A. As an example, and we just want to work through this, and I have my calculator so I can kind of work through it and make sure we all get the same answers. Suppose I have this one right here. So we'll say angle A is 52 degrees, B is equal to 22, C is equal to 35. So if I draw my triangle right over here, let's see, we'll say this is angle A, so that's 52 degrees. We'll say this is angle B up here, that's where we usually put it. So we'll put B as 22 down here. We'll put C as 35 over here. That's angle B, that's angle C, and this is my A. I want to find this side over here, lowercase a, capital B and capital C. And the way it works is using a formula. A squared is equal to B squared, B is 22, so 22 squared, plus C squared, 35 squared, minus 2 times B, which is 22, times C, which is 35, times cosine of the angle, which is 52 degrees. Plug all of that into your calculator. All of you can do that. Let's see. 22 squared is 484. 35 squared is 1,225. That's just some big number. Let's see what we get. $948.12. So then let's see. A squared is equal to 760.88. And be aware as you do these, your answers might be slightly different than the book's answers due to rounding as you're calculating these things. Do your best to try to keep it in your calculator and round it only on the last step. But now, for this, we have A squared equals 760.88. So to get A, square root both sides. Square root 760.88. 27.6. A equals 27.6. And we're good to go. And now, well, we have side A. All we're really missing on the triangle now is angle B and angle C. But in this case, if you want, you can use the law of cosines again to solve for angle C or angle B. I would say, just to make it easy on yourself, once you know this side, you have this ratio, an angle to its side, just use the law of sines. The law of sines will get you B using these two, and then once you have B, you'll have A and B, add them and subtract from 180 and you'll get C. As far as it goes for the solving of these triangles, there's kind of 3 steps. First, if it's a right triangle, use the Pythagorean theorem, use your SOHCAHTOA, get everything you need and you're done. If it's not a right triangle, then you try the law of sines. If you have a ratio, a side to an angle, law of sines, solve it all out, and then you can ultimately rely on the sum of the angles being 180 and things like that. If neither of those work, then your last resort is the law of cosines. And generally, use it once, like we did right here, to get, in this case, side A. And once you've used it once, you should then have enough information to use the law of sines or use some other trick to get the rest of the information from the triangle. Okay? Good. But, let's see. Well, suppose we have this right here. We'll do one more example. We'll say side A equals 24.6. Side B is equal to 16.2. And side C is equal to 33.5. So in this case, now for my triangle, I know all 3 sides. So this is A. This is B, and that's C over there. Now I don't have any angles, so I definitely can't use the law of sines. It's not a right triangle, at least not that I'm aware of, so I can't use any type of Pythagorean relationship. So I'm going to have to use the law of cosines here. The one issue that often arises here, when we're going to work through this one because students sometimes have trouble plugging everything into your calculator correctly on a problem like this, so we want to make sure we understand how to actually write it out. So let's see. Law of cosines says a squared equals b squared plus c squared minus 2bc cosine a. And in this case, I have all the sides a, b, and c, so I can substitute them in here, substitute in b for c here, and ultimately solve for cosine a. Once I have cosine A, take the cosine inverse, and I'll get my angle A. So let's see, we will get 24.6 squared equals 16.2 squared plus 33.5 squared minus 2 times 16.2 times 33.5 times cosine A. Now, pull out your calculator and do a lot of fun calculations. So, let's see, we get 24.6 squared is 605.16. I'm probably going to run out of room, but we'll try to make this work. 605.16 equals 16.2 squared is 262.44 plus 33.5 squared 1122.25 minus, let's see, 2 times 16.2 times 33.5 is 1085.4 times cosine A. Now here, do algebra. All of you know your algebra. We're solving for cosine A, so we have to isolate this term. So get rid of these. Subtract them over there. So just doing it all in my calculator, I'll get 605.16 minus 262.44 minus 1122.25 equals negative 779.53 equals negative 1085.4 cosine A. Now, we're isolating cosine A, divide the negative 1085.4. and we get 0.7181. So cosine A equals 0.7181. It's actually 819, so we'll round to 82. And now that I have that, do cosine inverse. And we get A is equal to 44.09. And apparently my angle A then is 44 degrees. Now from there, well, now I have a ratio between this angle and this side, so I can just use the law of sines to get angle B, and then I can easily get angle C. So from there, the rest of solving this out, I'm not going to take the time to do it, is pretty straightforward and direct. The one thing I would point out is we did all this work, and I'm going to erase this now because I'm sure all of you have it written down. We did all of this to get angle A, but if we remember from our law of sines, there's actually two angles that will give me a cosine of 0.7182. Well, what would they be? Cosine is the x value, so let's see. Well, in this case, the positive x value is in the first quadrant and the fourth quadrant, and that's going to give me a negative angle or an angle a lot bigger than 180, which means it doesn't actually work in this case, so I guess we're fine. We don't have to worry about it like we did for law of sines. So, we're good. There's only one possible solution. It's this one right here. Now, do the law of sines, solve the rest of it out, and you're good to go. Okay, this video is already long enough. There are some applications we could do. If you'd like to see some videos of our applications, just email me and let me know, and I'll post them up here. Either tomorrow or Thursday, I'm going to do more videos for the next section in your book, section 6.4, which you also have for homework. But I figure you can spend a few days working through the law of cosines and understanding how it works, and then we'll look at something else on Thursday. If there are any questions, as always, feel free to either stop by my office or email me.